Hello guys, welcome to the course P block elements. We are discussing the group 15 elements and we will be today discussing about the group 15 elements physical properties. Before the uploading of this lecture, we've already posted two lectures. Lecture number 1 was a brief introductory lecture and lecture number 2 we discussed about the atomic properties of the group 15 elements. So please make sure you watch the previous two before viewing this one. I am Dr. Ritu Johar from the channel H2O, the A to Z of chemistry, and I hope you're going to enjoy your learning with me. So before we start with the discussion, I just want you to look at a table which shows us the atomic and the physical properties. This is a table which has been given in the NCERT textbook. This is the table which I showed you in the previous lecture also while we were talking about the atomic properties. So in this table, we have the atomic number, the atomic mass, the electronic configuration. We discussed it in the last lecture. Similarly, the ionization enthalpy, the electronegativity, and the covalent ionic radius is what we have already discussed in the last lecture. So please do watch that lecture for a thorough understanding. Now today we will be talking about the physical properties. So we will be talking about the melting points, the boiling points, the density, and along with that certain more important points related to the physical properties. But please do remember that all these values which have been given, you are not supposed to mug them up. What is important is to look at these values and understand what is happening in the group. Whether the properties they are increasing or the properties they are decreasing, the trends are going to be important for us. So first of all, the trends in the physical properties of nitrogen family that we will be discussing today is going to be the physical state. So physical state means what? How are they going to exist in nature, whether they are going to be solids, liquids or gases. That is what you should be knowing. So please do remember the first and the important thing, nitrogen. So nitrogen, you all know this is present in the Earth's atmosphere as a gas. So nitrogen is going to exist as a diatomic gas, N2. Right, so you all have been writing about N2, O2 and so on. So you know that nitrogen is going to be a diatomic gas. In one molecule there are going to be two atoms of nitrogen. Now why is it so that nitrogen exists as a diatomic gas? Because nitrogen, this has a very small size, right? The general electronic configuration for these elements, it is going to be what? Ns2 np3. So nitrogen also needs 3 electrons to complete its octet. So how is it going to complete its octet? Well, it is going to complete its octet by the formation of a nitrogen-nitrogen triple bond. So each nitrogen atom has 5, makes 3 bond, so 5 plus 3 is going to be 8. So the octet is going to be complete. So it is by the formation of a triple bond that the trivalency of the nitrogen atom is going to be satisfied. Okay, now what does this triple bond mean? I hope you all know that the first one is going to be sigma bond, then the other two, they are going to be pi bonds. So nitrogen, because of its small size, can form an effective overlap of the pi orbitals, and the formation of the pi bonds is going to be good, and that is why we see the formation of a nitrogen-nitrogen triple bond. But when we look at the other members of the group, they all exist as solids. For example, phosphorus is going to exist as P4 molecule. Similarly, arsenic is going to be As4 and antimony is going to be Sb4. Okay, so all of these, they exist as solids. Bismuth is going to be a metal, so we will not be writing as bismuth 4 and things like that. Whenever we have solids, we just write them in the elemental form. Okay, because they're going to be a network of the various atoms together, which is going to be forming the crystal lattice for the metal. Okay, and now why do they do not form pi bonds? They do not form pi bonds because of their large size. The effective overlapping cannot take place, and that is why we do not see them as diatomic molecules. We see them as more than number, we see them as tetraatomic. All right, so you can look at the structures also. We have the structure of the nitrogen molecule over here, where we can see a formation of the triple bond, and then we have white phosphorus. Here you can see that phosphorus has having a tetrahedral structure. They are going to be present 4 molecules in the white phosphorus, and similarly the red phosphorus also we see that there is going to be one molecule having 4 phosphorus atoms, and it is going to be a polymeric structure. Okay. Now the next trend that we have to learn for the nitrogen family is going to be the metallic character, whether these elements they are non-metals, whether they are metals. So let us understand this. But before that, one very clear thing that should be able to differentiate non-metals from metals. So metals are going to be those elements which have a tendency to lose electrons, whereas non-metals are going to be those elements which have a tendency to gain electrons. All right. And when the elements they have a tendency to gain electrons, what does that mean? The elements will be having high electronegativity values, right? And they will be having high ionization enthalpies. And when I say that the elements they have a tendency to lose electrons, they are going to have low electronegativity values and they will be having low ionization enthalpy values. Okay, now when we are going to do a comparison, first of all, let us compare them with the group 14 elements. So with respect to the group 14 elements, these elements, they are going to be having higher nuclear charge, because when we are going to move from left to right in a period, the nuclear charge is going to increase, and also the electronegativity is also going to increase, right? So both of these they are increasing. So what this means is that there is going to be a tendency of the elements to gain electrons. So this means they are going to be more non-metallic or less metallic than the group 14 elements. Now what happens in a group? When the metallic properties they are going to increase going down the group. Why? Because the atomic size is going to increase, the screening effect is going to increase down the group. As a net total, what do you know? We know that the atomic size increases. When the atomic size increases, the ionization enthalpy decreases, the electronegativity decreases, right? So both of these they are decreasing. So this means that the elements they are moving towards a tendency to lose electrons and hence moving towards a tendency of a metallic character. All right. So what do we see? What we see is that nitrogen and phosphorus, they are going to be non-metals. Arsenic and antimony, they are going to be metalloids. And bismuth, this is going to be a metal. Okay. So this is important for you people to remember. Now, very importantly, I want you to remember the metalloids of the periodic table. This has been frequently asked in the examination. So that is why I wanted you to look over here, although we are discussing the group 15 elements, but I just want you to remember all the metalloids of the periodic table. So all these ones in the blue color, they are the metalloids. We have boron, silicon, germanium, arsenic, antimony from group 15, and then from group 16, we will be having tellurium and polonium also to be the metalloids. So these ones you are supposed to remember, and I'm going to give you a trick also to remember this. The mnemonic you can make yours also, right? So the trick is to remember that big sized giraffe has sub with T and polo. All right. So big is going to be boron. Sized we have silicon. Germanium from the giraffe has, I have taken up the as for a arsenic. Then we have sub for the antimony, and then T for tellurium and polonium we have polo. Alright, so big size giraffe has sub with T and polo. So please do remember all the metalloids of the periodic table. Now moving further, what I want you to remember over here that nitrogen and phosphorus, they are typical non-metals. So what we see is that they are non-conductors of heat and electricity. Arsenic and antimony both are metalloids, but what we find is that arsenic is a poor conductor of heat and electricity, whereas antimony, this is a good conductor. Alright, so the properties are having a regular transition from non-metals to the metals. And then bismuth, this is a typical metal, so it is going to be a good conductor of heat and electricity. Now the next trend that we have to learn is going to be for the melting and the boiling points, and this is a trend that is going to be important for you people to understand. So first of all, I want you to look at this table. This table is showing us the melting and the boiling points from the nitrogen to bismuth. I have written them down in the degrees Celsius. The table that you saw at the start of the lecture, the table which is given in the NCERT textbook, that is having the temperatures in Kelvin. So that you have a better feel, I've just converted them into degrees Celsius. No other reason for that. You do not have to learn whether it is in Kelvin or in degrees Celsius. Okay. All right. So now we have nitrogen melting point minus 210 degrees Celsius, phosphorus 44, arsenic 816, antimony 631, and bismuth 271. So what does this mean? What this means is from nitrogen to arsenic, the temperature they are increasing. From arsenic to bismuth, the temperatures they are falling. The question is why? All right. So you have to remember the trend and you have to remember the why. So first of all, the melting points, they are going to increase from nitrogen to arsenic because of the increase in atomic size. As the size is going to increase, we will be seeing that the melting points, they are increasing. Okay. Now the next we have is why from arsenic to bismuth, the temperatures they are falling, because here also the size is increasing. So why did the temperature fall? That is what is important for you people to remember. Okay, so first of all, let us read these lines and then I will be explaining you. So first of all, what we see is that the tendency of antimony and bismuth is to form 3 covalent bonds instead of 5, owing to the inert pair effect, which result in weak attractions between their atoms and lower melting point. Now what this means is, if you look at the electronic configuration, we have the general configuration to be NS2, NP, NP3. Okay. Now for nitrogen, we do not have d orbitals. So it is going to be a filled S and 3 half filled. So nitrogen can utilize these 3 for covalent bond formation, and this it can donate an electron pair to other atoms and participate in coordinate bond formation. So what we see over here is that nitrogen can show a maximum covalency of 4. But when we move on to phosphorus, arsenic, antimony, bismuth, all of them, they have vacant d orbitals, right? So from phosphorus onward, we will be having vacant d orbitals. So what can happen is one of this electron can move over here, and all of these, they can show a maximum covalency of 5. So they can form 5 bonds: phosphorus, arsenic, antimony, and bismuth. But what we see is that as we go down the group, the size of the atom is increasing, and what we see is that these two electrons present in the s orbitals, they have a tendency not to participate in bond formation. They behave as if they uh, are having a configuration which is stable, because the orbital is full and they do not want to participate in bond formation. And that effect is what we call as the inert pair effect, when the s orbitals, they do not want to participate in bond formation. And this tendency, this increases as we go down the group. That is why what we see is that antimony and bismuth, because of the inert pair effect, because these two s orbitals do not want to participate in bond formation, they are forming only 3 covalent bonds instead of 5. Okay. Now just understand that phosphorus can form 5 bonds, arsenic can form 5 bonds, antimony is forming 3 bonds, and bismuth is forming 3 bonds. So if you have to break 5 bonds, you will be requiring more energy. Here in case of arsenic, you will be requiring again, the size is also increasing and the bonds are 5. So what we see is that you have to require more energy to melt arsenic. Okay, I hope this is clear. But now when we move on to antimony and bismuth, here you just have to break the 3 bonds, because the s orbitals, they are not participating in bond formation. So as a result, there are going to be weak attraction between the atoms, because here there are 3 bonds and here there are 5 bonds. and hence we will be seeing lower melting points. Okay, so I hope this is clear that because of the inert pair effect, antimony and bismuth, they have a tendency to form three covalent bonds. Three covalent bonds between the atoms, the attractive forces are going to be less and the melting points, they are going to be less. Okay, and therefore you also see that from antimony to bismuth, the temperature is still falling further, right? So from antimony to bismuth, again because of the large size, this has a even lesser attractive forces for the other atoms. So the weak interatomic interactions are going to be taking place in bismuth than antimony. Okay, I hope this is very clear to you people, that the trends for the melting points are going to be from nitrogen to arsenic. Melting points, they are going to increase, and then falling from antimony and further to bismuth. So this is what you have to remember. Okay. The next we have is the boiling point. So that is going to be easy, that as the atomic size is going to increase, the van der Waals forces of attraction between the atoms, they are going to increase, and therefore the boiling points, they are going to increase. So this is going to be a regular trend in the boiling points that we see. There is no change. You can see that the boiling points, they are increasing throughout. Perfectly fine. Good. Now the next trend we have is for density. So nitrogen, this has low density, and as we are going to go down the group, the density is going to increase. Now why is density going to increase down the group? Because density is mass by volume. So as we are going to go down the group, the atomic masses also, they are going to increase, and the atomic size and the atomic volume is also going to increase. But what we find is that the mass dominates over the atomic volume, and hence there is an increase in the density as we are going to go down the group. So now the next trend that we will be learning is going to be allotropy. So first of all, what do we mean by allotropy? Well, this is the ability of a substance to exist in more than one physical form. For example, in class 11, you studied about the group 14 elements, the carbon. So carbon also shows allotropy. It exists in more than one physical forms. For example, it exists as diamond, it exists as graphite. And similarly, now we have the group 15 elements. They also show allotropy. And in fact, all the members show allotropy except bismuth. Okay, so except bismuth, all of them show allotropy. For example, if I talk about nitrogen, it exists as alpha and beta nitrogen. Then we have phosphorus, which exists as white, red and black phosphorus. Then we have arsenic, which exists as yellow and gray arsenic. And antimony, this exists as yellow and silvery gray antimony. Now, one very important thing I would want to tell you people over here is that in the NCERT textbook, what is given is that except nitrogen, all members show allotropy. So please do remember, it is not the case. Nitrogen shows allotropy. Bismuth does not show allotropy. Okay, but if it is a question in your paper, well, the NCERT textbook is always going to be correct. So please mark nitrogen does not show allotropy. Okay, so that is what I want you to be doing, because for your examination, the NCERT textbook is going to be important, but I did not want to give you a wrong information also. Now the next trends that you have to learn is for the catenation. Okay, so what is catenation? This is the self-linking of atoms, the ability of the atoms to form long chains with the atom of its own kind and of the different kind also. Okay, and this is what property that you have studied in detail in relation to carbon. So carbon, this has the ability to form long chains. And why is it so? Well, that is because it forms stable carbon-carbon single bonds. But now when we are going to look at the elements of the nitrogen formulae, they also show a small amount of catenation. Okay, so what we see is that the group 15 elements, they exhibit catenation, but to a much lesser extent than carbon because of the bond dissociation enthalpies. So if you look at the bond energy for the carbon-carbon bond, this is high, 353.3 kilojoules per mole. When we look at nitrogen, this is less, 163.8. So the carbon-carbon single bond is much more stable, and that is why they have a tendency to form long chains. Nitrogen, this bond is not that stable. Then phosphorus, it is 201.6. Then we go on to arsenic, it is 147.4, and it is going to decrease further. Okay, so we see that there is a tendency even in case of the group 15 elements to show catenation, but not to that extent, because the single bonds, they are not as stable as we see in the case of the carbon-carbon single bonds. Okay, so nitrogen can attach up to 3 atoms in the azide ion and hydrazoic acid, that is N3H. Here nitrogen N3 is having -1 charge. Okay, and then we have phosphorus, which exists as both cyclic and open chain compounds containing several atoms of phosphorus. For example, we have a molecule P2H6 diphosphine. So this has two phosphorus bonds, two bonded together. Okay, so now what you have to remember is that if somebody asks you which is the element in the periodic table which has the maximum tendency for catenation, it is going to be carbon. But if somebody asks you from the group 15 elements, which is the element which is going to have maximum tendency for catenation, it is going to be phosphorus. Okay, so this is what you will be remembering over here. So now this is the end of today's discussion, but we are going to see a few questions, the lecture review question, which will help you recap today's lecture, see the most important points for today's lecture. So question number 1, for the group 15 elements, the correct increasing order of the melting point is, and the choices they are given. So I would like you to first of all choose your option and then look at the solution. So if you've done that, let us look at the solution. I hope you all remember that the melting points, they are going to increase from nitrogen to arsenic, and then from antimony bismuth they are falling. So what we find is that nitrogen, first of all, the lowest melting point, then phosphorus, then it was bismuth, then it was antimony, and then it was arsenic. Okay, so we have first of all nitrogen, then phosphorus, then we have bismuth. So these two options, they are seeming to be correct. Then we have to move on to antimony, and the highest melting point is going to be for arsenic. So the correct option is going to be C choice. The next question is, among the group 15 elements, the element which shows maximum catenation. So I've already told you it is going to be phosphorus, which is going to be showing maximum catenation. So it is going to be B choice. So now the third question is, which of the following is not a metalloid? So I've told you all the metalloids of the periodic table. So choose your option correctly. So the correct option over here is going to be C choice, bismuth. We have just now learned today that bismuth is a metal. Arsenic and antimony, they are metalloids, and nitrogen and phosphorus, they were non-metals. So bismuth is a metal, not a metalloid. The last question for today, among the group 15 elements, the element which does not show allotropy, and the choices are antimony, phosphorus, bismuth and arsenic. So nitrogen is not given over here. So I hope now you will be able to, without any confusion, choose the correct option. So the correct option is going to be C, bismuth. But in case nitrogen is given in the examination, so please be very careful, because in NCERT it is given nitrogen does not show allotropy. Okay. So now before we conclude, there is one more thing that I have for you people, and that is a have an edge section. A section which is going to help you excel, have an edge over your competitors. So what are we going to do over here? Well, we are going to put up all the trends that we have learned in today's lecture, and in fact what we have learned in the previous lecture, the atomic properties also, all at one place. Okay, so what we can see over here is the properties like ionization energy and electronegativity, they are going to be maximum for nitrogen because it has the smallest size, and as we are going to go down the group, the size is increasing, the ionization enthalpy decreases, and the electronegativity also decreases. So nitrogen will be having the maximum, down the group bismuth will be having the least values for ionization energy and electronegativity. This is what we learned in the last lecture. Now the next we have is the values for which nitrogen is going to be having the least value continue down the group, bismuth will be having the highest values. So atomic size, ionic size, atomic volume we learned in the last lecture. Today's lecture we learned about the metallic character increasing down the group. Nitrogen and phosphorus, they are non-metals. Arsenic and antimony, they are metalloids. Bismuth is a metal. So metallic properties, they are increasing down the group. Boiling points, they also increase down the group with the increase in atomic size, and the density also increases down the group. Okay, so this is what you have learned, and the one very important trend that we have learned today is for the melting point, where there is not a general pattern that we generally see. So nitrogen, phosphorus, bismuth, antimony and arsenic, this is going to be the trend for the melting points. So just remember, from nitrogen to arsenic, the melting points, they are increasing and then they start falling for antimony to bismuth. So this will be, arsenic will be having the highest melting point. Okay. So that would be all for this lecture. I hope you enjoyed your learning with me. You have understood the very important trends that we have been discussing today, and you are going to join me back for the next lecture. Next lecture, I'm going to be talking about the oxidation states of the group 15 elements, which is going to be again very, very important for you people. So see you again. Have a nice day. God bless you.